In this video, we'll be looking into 16 important homologous series in organic chemistry. So this is the part B video. So I've made video on the part A, whereby I started from number 1 to number 10. So this video is the part B, which is the number 11 to 16. So in our part A video, we've talked about alkane, alkyne, alloalkanes, alkanol, and so on. So in this part B video, we'll be starting with alkanamides, also known as what? Amides. Before I proceed, if you want an online tutorial, so like one-on-one tutorial, you can actually say that under the comment section. So probably you can give us a mail through our email address, mathchemtutorial@gmail.com. So if you want an online tutorial, one-on-one tutorial in chemistry, any aspect in chemistry, even if you are in secondary school or if you are in any grade from grade 1, 2, 3, 4, anything. So if you need chemistry tutorial online or probably mathematics, any one of the two, even if you are in 100 level university, you are in colleges, any level, so we can handle that. So now let's look at the alkanamides, also known as amide. If you observe the number 14, 15, and 16, you will see amines, and you see number 11 as amide. So when I get to 14, I will explain the difference between the two, amide and amine. Please don't forget to share this video and ensure to watch the part A video as well. Share this video to your classmates, share it to your friends, share it to your family who are also science students. And I believe that all science students will definitely do chemistry, and all students offering chemistry will surely need the knowledge of organic chemistry. So I'm very sure that this video is going to be helpful to a lot of science students who are still learning. Okay, so now let's start with alkanamides. The general formula for alkanamide, also known as what? Amide, is before that, let me just brief you on what we call alkanamides. Alkanamides is like from the word alkanes and amide. And you know, amide, even from the word amide, it sounds like amine. And you know that amine is from where? Ammonia. And you know that ammonia is a what? Is a gas. Yeah, it's mostly in a gas, and also it is a base. Exactly, is a base. So all these amine, primary amine, secondary amine, tertiary amine, with the alkanamides, they are also a base as well. And even in terms of electrolyte, they are weak electrolytes. So, but don't let us go there. So now, the alkanamides now, the general formula is RCONH2. RCONH2. So that's the general formula for alkanamides. Okay. Now we already know that R is what? Alkyl. I've explained that in our first video, in the part A video. So such as methyl, ethyl, propyl, butyl, pentyl, whereby this is the CnH2n+1, whereby the N is the number of carbon atoms. So if the number of carbon atoms is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, as you can see it here. So the general formula for alkanamide, also known as amide, is RCONH3, whereby the functional group is going to be bond CONH2. So that's going to be bond CONH2. So how will the structure look like? Let me show you here. Look at this place. Please center on this place. The structure is going to look like something like this: RC double bond O bonded with NH2. Now look at this guy, this nitrogen. Nitrogen can bond with 3 different things. You understand? So if I should draw this properly, that's going to be RC double bond O bonded with N, N bonded with H, and H. So this is how the structure of alkanamide is going to look like, whereby your R can be any alkyl members: methyl, ethyl, propyl, and so on. So now, what is now going to be the name? Now let's name. If this R is methyl, you understand? That means CH3. Now count the number of carbon we have here. number of carbon we have, number of carbon we have here is going to be what? 2 like that. You know, this guy, if this guy is CH3, so you're going to be having 2 carbon atom. So if you have 2 carbon atom, that means it's going to be what? Ethylamide. Ethylamide. So you're going to end the suffix with what? Amide. Ethylamide. Okay, so that is that about. Now let's move to acid anhydride. Is the combination of two carboxylic acid, also known as 2-alkanoic acid. So now, how does it look like? Now look at the board. Please observe this place very well. If we have the carboxylic acid or alkanoic acid as RCOOH, you know, the general molecular formula of carboxylic acid or alkanoic acid is this. So plus, let me write this guy backward. Let me say HOOCR. Did you say that now? So from here now, let me remove water from these two guys, OH here and H here. So what am I left with? I'm left with RCOOCR. Correct. So this is the general molecular formula of acid anhydride. It's just like as if you are removing water from where? So from 2-alkanoic acid, or you call it carboxylic acid, whereby your R is your R is what do they call it? Your alkyl, which is all these guys we have here, methyl, propyl, and so on. So the general molecular formula for acid anhydride is going to be RCOOCR, which can also be RCO3CR. Now, let me just give you a sketch of how the structure may possibly look like. Okay, now observe this. Let me clean this guy. Let me clean this. Please do like to share this video to your classmates and encourage us by giving us a super thanks. If you have the money to do that for, I think it's going to cost a little token, and join our membership platform if you want an online tutorial on mathematics and as well on chemistry. Please do have to give us a mail on our email address, mathchemtutorial@gmail.com. So the structure of this acid anhydride is going to look like this: RC, then this is going to be the double bond O for this particular O here. So this oxygen here is going to come like this, O here. This oxygen here is going to be this oxygen here is going to attach to this carbon here. So this C here is this. Then this O here is going to be here like this. Then we have our R here. So this is how the structure of acid anhydride used to look like. Let me write it again. This will be RC double bond O attached with O. You understand? So this guy, this O here is now attached to carbon, whereby carbon is attached to double bond O, and we have our alkyl here. So this is how the structure of acid anhydride used to look like. Now, what about the functional group? The functional group is just going to be bond CO3C, or probably you say C2O3. So that's going to be bond C2O3. Anyhow you write it, probably you can put R, doesn't mean. So let's look at number 13. Number 13 is alkanol halide. Alkanol halide. This is from carbonyl halide. You understand? Carbonyl halide. And I told you that carbonyl comprises of what? Alkana and what? Alkanone from the part A video. So now, how will it look like? It's like as if I am combining carbonyl. Carbonyl, the one for alkana is RC double bond O. Then here is R. This is for the alkanone. And for the alkana is RC double bond O bonded with H. So this R and this H, they will be substituted with what? Halogen. That is what? X. They will be substituted with what? I mean, they will be replaced with what? With X. And that X is halogen. And the halogen is fluorine, chlorine, bromine, iodine, and so on. So if this R and R here is replaced with X, then this becomes alkanol halide. Or probably if this H is replaced with X, is also called alkanol halide, also known as carbonyl halide. So now, what's going to be the general molecular formula for that? That is going to be the RCOX. RCOX. You know, the X is replaced with what? I mean, the R is replaced. I mean, the X is replaced with this R or probably this H. And this guy here is the alkana. This guy here is the what? Alkanone. So what is going to be the functional group for that? So the functional group is going to be bond COX. Bond COX. Bond COX. Sorry about that. So that's going to be bond COX. Now let's look at number 14. Number 14 is primary amine. Primary amine, the symbol of primary in chemistry is written as 1 and this knot or degree, anything you call it. So this primary amine, you know, amine is obtained from where? Ammonia. Ammonia, which is a base, a weak base for that matter. So amine is obtained from ammonia, and then amine is this, NH2. So primary amine just simply means that if you combine an alkyl together with NH2, that gives you primary amine. And remember that I said that that nitrogen usually bond with 3 different things. That is one of the nature. So it's bonding with R, also bonding with 2 hydrogen. So the structure will look like this: R bonded with N, this N with hydrogen and another hydrogen. So this is primary amine. So now let me write the general molecular formula. That will be R bonded with NH2, whereby the functional group is going to be bond NH2, as you can see. So now, what about the name? Let's assume that if this guy, this R here is ethyl, that is C2H5. So what's going to be the name? The name is going to be ethylamine. 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 So that's going to be the name for that. And what about if this R is butyl? That's going to be what? Butylamine. You get that now. So let's go to number 15. That's the secondary amine. Secondary is written as this guy. Look at this guy, 2 and the knot here. So secondary amine just simply means that if you clean one hydrogen here and you replace it with what? Double bond. So that simply means secondary amine. So how is it written? It's written as R double bond NH. But mind you, that R now, you know, R is usually methyl, ethyl, propyl, butyl, and so on. So this R now is going to represent CH2 and no longer CH3 in case of methyl. You understand? In case of methyl. What about for ethyl? Ethyl is C2H5 bar. Okay. So for this guy now, this R is going to represent C2H4. Why? Because if for the case of CH3, which is methyl, if this guy represents CH3 and not CH2, that means the carbon is going to attach with what? With 5 different things. If it is CH3, if there is CH3 here, that means you're writing a wrong compound in organic chemistry. So your R here is going to represent CH2 and no more CH3 in case of methyl. So the general molecular formula for this is going to be R double bond NH. R double bond NH. So, and also the functional group is going to be double bond NH. Double bond NH for that. So that is the secondary amine. And then for the tertiary amine simply means that the remaining hydrogen in the secondary amine is going to be what? It's going to be eliminated away, and then you replace it with the triple bond, meaning that nitrogen will be triple bonded with alkyl, and that's going to be R triple bond N. R triple bond N. So meaning that there will not be nitrogen again for the tertiary amine, and the symbol is 3 raised power what? Degree, something like that. So this guy is going to be R triple bond N, and this is the tertiary amine. Now, what's going to be the functional group? Before I write the functional group for this tertiary amine, please don't forget, ensure to give us a like thumb, share this video to your classmates, to your friend, and to those who really need this video, I mean science students. give us a super thanks if you have the money. I guess it requires little amount of token to support us, encourage us. It's not easy uploading videos, making videos for you guys for free to watch and learn. So try to encourage us. Join our membership forum and share this video. Let it go viral. At least help others. Don't be selfish. So help others. So now the functional group for this tertiary amine is going to be triple bond N. Triple bond N, as you can see it here, triple bond N. So that's going to be the functional group for this tertiary amine. So please share this video to your loved ones, to your classmates, to your friend. Give us a like, a nice comment, and thank you so much for doing that. I love you so much. Bye.